to interview on primary water. He has the Primary Water Institute.
Yes.
I just start out with where does this idea come from that there's a huge amount of this water in the, what is it called, the crust of the earth?
Yes. Well, you know, Tim, I don't know if you've ever thought about it very much, about water particularly. The concept of water is really a enigma in that you have two gases. One is hydrogen and the other is oxygen. You know, and so H2O makes liquid, which is pretty preposterous when you think about it, in as much as, again, hydrogen is one of the most flammable of all materials on the planet, and oxygen must be present for combustion. So theoretically, this water is very explosive, and our bodies are made up, almost 2/3 of our bodies are made of water, roughly the same ratio as the oceans versus dry land. And another added interest is in that the oceans, their salt content is roughly the same as our blood. So you go ahead and think on that just a little bit if you have time, and you wonder how did it happen? That's what got my attention some 60+ years ago, is when this guy held up this glass of water and says, you know, wondered if we knew where it was and where it come from and the constituents. And you know, thinking on it more, why it makes a whole lot of sense that the water did originate with the planet, and through some transformation, the Creator has made this liquid out of magma, and it's still making it. In other words, we have new water coming up all the time as the planet is very much alive. Down below, as you can see, the volcanic activity and the water that goes with it. Anyhow, just a food for thought.
Yeah. What about it coming up through this distance from where it is created? Doesn't it become contaminated by what I guess we call the poisons in the earth?
Well, you know, everything on this planet, pretty much, be it metallic, mineral, or not, actually originated with magma. And you know, it's not all of it is fantastic. Like, for example, take arsenic, for example. The source of arsenic, that deadly poison, is from arsenopyrites. Pyrites, iron pyrites that are, in fact, pushed up out of the magma, separated from magma, and become iron ore. As one of the iron ores is arsenopyrite. There are other pyrites that don't contain arsenic, but exactly every element in the periodic table originated with this planet and with magma. So as it comes up, you know, now they have, I don't know if you have read any of the latest scientific issues, but this ringwoodite, this one piece of stone, which is harder than diamond, the scientists here last couple of years subjected that ringwoodite to pressure and heat, and they extracted water from it. So, you know, the mystery grows, but consensus that the Earth contains considerably, several times more water than what is on the surface, down below, in different forms. Some of it are basically in rocks. For example, in granite. You know, if you could subject granite to the kind of heat and pressure that is down below, you would 40% of that is actually water, or the makings of water, and the rest of it are different minerals. But it's not my idea. This has been now investigated, and the idea has been around for well over 150 years. Originated actually in the Scandinavian peninsula, before the turn of the century.
It's just interesting to think how we've got gravity, and then we see it pushing down like the weight of the ocean, and all that pressure pushing down through whatever cracks or faults there are in the earth. And this is kind of like something that's being pushed up in the magma.
Indeed, because when you look at the continents too, originally we were a piece of molten lava that spun off the sun, and we ended up being in orbit around the sun. All of us. I mean, we are all related very intimately, like it or not. But good ones and bad ones, etc. I'm not here to. It would be easier to sell religion than actually have people to think on this. People normally get worried about stuff that they don't understand. Well, I don't understand how it was made either, but it had to be come from magma, because that's all there was. I mean, you can make fun and say, well, the Martians didn't come by and throw little ice cubes at us to make all this water. But if you look at the continents, Africa perfectly fits to South America. Now, at one point in time, that they were all together, but with these fractures or faults, and when water came in, water required space, and it pushed these continents apart, and it's still doing it. This continental drift is still going on. I mean, Africa is portions of it is separating from the other parts. Why is it doing that? Water is coming in between it, and water, you cannot compress water. You can easier compress anything else than water. It's really a remarkable substance, because in the form of steam, yes, you can compress as long as it's gaseous, but the minute it becomes solid, these two elements come together, it's not compressible anymore.
Yeah, it is amazing, isn't it, how water is different from
the only
other things.
That behaves totally unlike anything else, because the properties are, when it gets hot, it contracts. When it gets cold, it expands. Totally unlike any other element.
Yeah. Yeah. It is fascinating how it works. And why doesn't water on these tectonic plates or whatever they are that are changing on the surface, like you're talking about the water's ability to make them move, why isn't the water shooting up like giant geysers in places for a mile or?
In some places it does. I mean, look at the Old Faithful, for example. And now there's a very poor explanation of how that water got hot and why it comes on all the time. Well, now if you think about it for a minute, that Old Faithful goes off winter, summer, and fall, whether there is a drought or no drought. It would appear to me that there's some sort of a lid that has to build up so much pressure, and when it builds up so far, then it releases. Then it releases the steam and hot water. Well, and it doesn't matter whether it's raining or it rained or didn't rain, or winter or any other time of the year. It does it the same periodic intervals, and obviously that water and that steam, that pressure is building up, and the slid flips open long enough to release it. Especially in that volcanic system, because that is one large extinct volcano, and that it has all different types of waters that bubble up. Some are very highly mineralized, others are not. It depends on where the contact is. It depends on what it comes into contact on its way up, because hot water tends to dissolve very quickly, and water is in fact a solvent. That is the universal solvent. That will dissolve after a while almost anything and everything.
I was thinking how it seemed like here in our southwest Oregon, and you go up on the mountaintops about 5,000 feet, and water comes out of the mountaintop in spring.
Rock.
Even
out of rocks, actually. When you look at some of these freeway cuts or road cuts into solid rock, they have to dewater. All the time, water is seeping, pouring out of those fissures, and yet it is solid.
Yeah, I was thinking that because of the Rocky Mountains being higher, and like Crater Lake here in the southwest Oregon area, I was kind of thinking it was like gravity, the water pushing down and finding its faults and coming up at the lower, like 5,000 feet, compared to where it was made in the other parts of the earth.
Well, maybe some of it is commingling, but you take other places like the Great Sahara Desert. I look at all the oases out there in the middle of absolutely nowhere. For hundreds and if not 1,000 miles, there are no mountain ranges or nothing. It doesn't even rain there. Now that would be very difficult to make the connection with those oasis water and the Rocky Mountains. That's oceans away. In the meantime, you have all these faults that are actually open to not only water penetration, but as conductors from down below. They have to be coming from down below. They are not coming. If they are not coming from the sky, where else are they going to come from? And originally, what's with that? This was a molten piece of real estate, all of it, and yet it is now the water planet. And right now, as we speak, there are countless numbers of vents, hot vents, in the bottom of these different oceans. And some of those waters that are bubbling up are pure, and others are noxious, laden with all kinds of minerals that are not good for anything. In the ocean, of course, they all get commingled, and they establish roughly a balanced, saline content. But again, the different parts of the oceans, the great oceans, have slightly differing contents of metals and sodium, and metals too. All these metals are actually bubbled in with superheated water, deposited. Gold, silver, all the iron deposits, mercury, they're all deposited from superheated waters. And gold, as far as I'm concerned, the manganese oxide, that black material that they had over here by Gold Hill, Southern Oregon. Those gold deposits. The only way you can tell where they had them and still do, indicators are those manganese stains, black. And when water comes in these fissures too, I've drilled countless number of wells. The very, very important indicators in drilling them, because I'm drilling it into solid rock. I'm not drilling it into an alluvial fan. In other words, not sand and gravel. I can't drill into sand and gravel because that tends to collapse on and locks in the drill bit. So I drill in solid rock, and it's a jackhammer like a drilling machine, still rotary, but it hammers as it drills, and the dust that is that pulverized, that the granite, say, that is being pulverized into dust, is blown out. And the minute you hit water, you can tell exactly at what depth. But before that, the indicators are suddenly for example, that white dust that you're blowing out starts to turn gray, and black. Now that is the manganese now that is within those granite material, granitic material. And then of course all of a sudden there is quartz and contact water. But the water, normally the first batch of water that comes out of there, you would think you just hit some oil because that manganese is so light it travels on top. So those are indicators, and I look for those and so forth. There's quite a bit to the study of where they are located, what faults are indicators, and et cetera, because I just look at topographic maps and I pretty much can tell where the likely structure is to search for. I've drilled countless number of wells now that I anyhow. There's so much to the subject that unless you ask questions, I don't even know what end to start with.
Yeah, I was just wondering why you were talking about the manganese and drilling and the indicators. Have you ran into ore bodies like for the precious metals in the drilling?
Of course.
It's just how deep do you drill?
No, not how deep. It is the rest of the country rock would give you indication. For example, I drilled a couple of wells where the drilling itself paid for. I mean, the value was just blown out of there, washed out of there, paid for the drilling costs.
Oh wow, yeah, sounds like you hit some rich ore.
Invariably, they are too far down. And again, they are with water, so water then represents a problem.
Mm-hmm.
You see what I mean?
Yep. Sure, it'd be coming in constantly if you were trying to get down there and extract the ore. Yeah, I do know. Just like over at Gold Hill in the Sylvanite mine, it's about 1,000 feet deep, and that's got the water squirting in out of the side walls like under pressure.
It's always with. Remember, Tim, the old Steve Riess, he was a mining engineer, actually. He worked for the Hoover family, the ex-president Hoover, because those people had interest in gold mining, not only here in the U.S., but overseas in Australia and South Africa. Steve was Bavarian born. He was from Germany, actually, Bavaria. And he was a mining engineer, so he worked for them, and that's how he encountered water way up on top of the Sierras. One of the highest points. They were driving a tunnel, and he said, they were already in about a mile and a half, almost the highest point. Which peak he said it was, but he said there was one day because he was the one. They would basically blast Monday and then muck all week, sort and muck all week long, and then again Friday they would drill and set charges, and everybody goes home. He's the last one to go, and he said this one time they drilled, set the charges, and everybody left already, and he's always the last one to leave. And he says he heard this hissing sound. He thought, my God, what the heck is that? So he was listening. He was coming from somewhere, from one of the holes, and he thought, gee whiz, maybe there's something wrong with one of the charges. Anyhow, he couldn't establish, but Monday, when they blasted, they all of a sudden, here come this river of water in. They went all the way to the end, where there was this shear zone. It was a vertical shear, and as soon as they penetrated that shear zone, here comes a ton of water. They were on the Nevada side of the Sierras, so can you imagine? He says there was no pump big enough to handle all that water. The same thing.
Yeah.
Same thing really is with the Tombstone silver mine.
Yeah.
I've
heard about the underground river.
Yeah.
Yeah.
Now, where and there you are, out there in the desert, on the mountaintop. Now the water obviously didn't come from anywhere top. That's the highest point. So it had to come from the bottom. But he says the interesting part over there in his mind, he says the water was cool. It wasn't, It was like maybe 65 degrees. Normally, he says, they are hot. But even I've seen one hot spring in Agua Caliente down in Mexico, just a little bit north of Cabo, about maybe, let's see, how many miles? I'd say probably 60, 70 miles maybe. On the Sea of Cortez side, there's a place called Agua Caliente, where the water literally spritzes out of the solid rock. But that water is quite warm, 95 plus degrees. The crazy part about it is that it almost has no minerals. It's almost totally devoid of mineralization. The best water, not warm. Now, why it doesn't? It must have dissolved everything. It must have been running forever, and there was nothing else to dissolve. But the other side of that peninsula is Todos Santos, and that has a spring, a first magnitude spring. That spring produces 50,000 to 100,000 gallons of water a minute. There's no rain down there. Directly on
that's
the
a
other
lot.
side. Yeah, that's a lot. And it hasn't rained there. I mean, it doesn't even rain. I believe it maybe rains 7 or 8 inches a year altogether.
Yeah.
7, 8 inches is not enough. It would you put 7, 8 inches of rain in a bucket and set it outside and see how long it lasts in the summertime.
Yeah.
But I suspect even the crater lake here, because you see the sidewalls of that crater, in my opinion, produce the water that is coming directly up, because the crater lake doesn't change very much in volume. You notice that?
Yeah.
It doesn't matter. It's always right there.
Of that.
It doesn't matter how long of a drought or what time of the year. It's right there. I think it starts the Rogue River, doesn't it?
Yeah. Yeah, I was thinking it was from the rain and the snow melt all the time, keeping the great big caldera full.
When you get into these droughts, the same thing with California's Clear Lake. That is probably North America's oldest extinct crater, and that's misshaped now because of the movement of the San Andreas, and it's been extinct, no telling how many million years ago. But that water in Clear Lake too, even in the highest drought periods in California, it pretty much remains the same. And look at the surface evaporation there. Doesn't matter. Parts of that, Clear Lake has good water, and other parts of it, no. The south part, and you can see the banding of the mineralization sometimes when you go in the winter, when all the leaves are gone from the trees. You can see the coloration of the structure itself. The water comes through, and some places there is actually native mercury there that enters the lake, natural. Of course, normally the miners get blamed for that. Just like when you look at the Klamath River, one of the biggest mercury mine was right off of Empire Creek, where you could mine native mercury. That's what I used to get, just go in there and get a bucket of what that gouge, that gouge, hardened gouge, that blue stuff, and just grind it up and pan mercury out of that. I never bought my mercury.
Yeah.